In the last lesson, we talked about function notation, and here I'd like to more carefully define what a function is. So we talked about a relation being a graph. So like here I have a graph. It's really just a set of points. Same thing over here. I have this other relation in that it's just a few points that I graphed. So these are both relations. Now a function is a relation, so it could be this or this, but it has the following extra property. Every x value in the domain relates to exactly one y value in the range. Let's examine this definition by looking at example 1. So like I said, here we have a collection of points, here we have a collection of points. This means they're both relations, but are they in fact functions? I'm going to start with this graph here. I'm going to examine the points that are on the graph, and I'm going to write down what the domain is and what the range is. So let's begin. The domain is going to be every single x value for the corresponding points on my graph. So like this point here has an x value of -4. That means that -4 is in the domain. Notice that there's nothing at -5 that I can see, so -5 is not in the domain. So we kind of like, okay, this is the first spot, that's its x value, let's move on. Okay, I have this point here. Its x value is -3, so -3 is in the domain. This point here has an x value of 0. We also have, this point has an x value of 2, and this point has an x value of 3, so both 2 and 3 are in the domain as well. And as far as the range goes, that's going to be the corresponding y values for these points. So for this point here, the corresponding y value is -1. So we get -1 is in the range. Likewise, at -2, I don't see anything left or right, so -2 is not in the range. I'm not going to write it down, but -1 is. I move up to this point here. +1 is in the range. So is 3. And then so is, well, these both have a y value of 5. You could copy down 5 twice, but I think it's fine just to say like once. We got 5, we got it a second time, but I just have to reference the number that is there, and it is 5. So great, I have my domain and range. This condition says if I pick an x value in the domain, how many y values does it go to? So this x value of -4 goes to this y value of 3, and it doesn't go to anything else. So for this one spot, this condition is met. I look at this x value, and there's only one thing above it. There's nothing anywhere else. So let's check this x value. I look down to this point, and there's not a second one. So this x value relates to this y value, and that is all. Moving along to 0. 0 relates to 5. It doesn't relate to anything else, so we're good there. I move to this point. This point is x equals 2, y equals 5, but that's it. There's nothing else above or below. I go to this point here. The x value is 3, the y value is 1. I don't see a second one. So according to this definition, this thing is a function. Perfect. So it must be that the other one is not, but let's examine why. Again, going through it carefully. So maybe just a little bit quicker this time. If I want to look at the domain, if I look at the points, we get -4, -1, 3, and 4. So -4, -1, 3, and 4. These are the only places for x where the graph exists. And for the range, the only y values that we get are going to be at -2, +1, +3, and +4. So that was -2, 1, +3, and 4. All right, so starting with this x value, I only have this one y value, so far so good. Here's a problem. This is why this graph, this relation is not a function. I have the x value of -1, it goes to 4, but it also goes to -2. this violates this condition. We have, I'll write it off to the side, x equals -1 went to y is equal to 4. And at the same time, x equals -1 went to y is equal to -2. That is a single x value going to two different y values. The second this happens once, you don't ever have to keep going in terms of, is this a function or not? This thing is not a function. I mean, it is true that at 3 you get only 1 point, and at 4 you get only 1 point, but the fact that it went wrong once means that this thing is not a function. So this relation was, this one wasn't. But what if your graphs are more complicated? So they're not just like a couple of points that you have to check. So both of these relations, in that they're graphs, they both have infinitely many points. But there's this really nice visual way to check to see if something is or is not a function. It's called the vertical line test. If there is a vertical line that passes through the graph more than once, the relation is not a function. So let's start with this one here. This is a circle, its radius is 3, but is this graph, is this relation also a function? If I can find just one vertical line that goes through the graph 2 or more times, this is not a function. And that is a very easy thing to do. Here's a vertical line that goes through the graph twice. This is not a function. I mean, essentially what this test is saying is that you're choosing one x value and it goes to two different y values. But if you understand that portion of the definition, this is just a nice thing that you can graph. So this vertical line went through the graph twice. It means it's not a function. There were a lot of correct answers here. You could have picked the vertical line over here, or the one right at 0 for x, or at 1. So there's a lot of choices, but you only need one for it to go wrong once. Now if we compare that to the situation over here, it's got to be okay that this is a function. But the reason it works according to the vertical line test is no matter what vertical line you draw, okay, that one didn't work, right? So this vertical line just went through this 1 point. Okay, I'll try somewhere else. I'll try over here. Still no good. I'll try here. No matter what vertical line you draw, it's only ever going to go through the graph one time. And if that happens, that means that this thing must be a function. So that's pretty much everything you need to know about something being a function. If you can look at its graph, you can use this test to see if it is or is not a function.